Good day, my name is Kurt Emil Eriksen. I'm going to give you an introduction to Active Hous. What is Active Hous? What have we worked with? What is the specification? And how can you work with the specification and the radar? Active Hous started already back in 2008, just after the European Commission came with their 2020 plan for 20% CO2 reduction, 20% renewable energy and 20% energy efficiency. Just after we got a new Energy Performance of Buildings Directive, the recast, introducing nearly zero energy buildings and asking the member states to implement nearly zero energy building requirement for new public buildings by the end of 2018 and for all other kind of new buildings from the end of 2020, and to use the nearly zero energy building level for major renovation. We know that 40% of the world's energy is used for heating and cooling of buildings, and we also know that 90% of our building stock will still be in use in 2050. Therefore, there is a huge potential for the construction sector in order to go in and reduce the energy use in buildings, reduce the CO2 emission from buildings, and we have an obligation to do so. However, we also know that 90% of our time is spent inside buildings, and 30% of the buildings mass do not provide a healthy indoor climate. This is also issues that are important to keep in mind. There's one reason to build a house, and the reason to build a house is that people should be inside the house, and therefore we have to take the starting point in the indoor comfort of the building and then design building with a minimum use of energy and minimum CO2 emission. We know that climate changes are global. We know that our resources are limited. We know that the waste from the construction sector is growing, and therefore we also need to focus on sustainable issues, climate issues, environmental issues. So altogether we need to focus on comfort, energy and environment. We can act now. The construction sector has proven through a number of projects that we can already today build nearly zero energy buildings. We can build those kind of buildings with the technology that is available today. It's just a question about how we use it. Based on this, a number of companies moved together in 2009 and established the Active Hous Alliance. It was international organization and networks, it was the building industry, it was universities and researchers who moved together. The building industry is the complete supply chain in the building industry, going from the manufacturers over the investors, the architects, the engineers to the end users. So it covers the whole supply chain. We have a target group outside our network, which is the end users, the communities and the politicians. We would like to show end users that they can live, play and work in sustainable buildings. We would like to talk to the communities and inform the communities that Active Hous is a solution for the new cities around the world. And we would like to tell the politicians that Active Hous is one of the solutions to nearly zero energy buildings, and that it is available already. One of the first things that the Alliance did was to create the vision of buildings that give more than they take. Active Hous is a vision of buildings that create a healthier and more comfortable life for their occupants without impacting negatively on the climate. The vision is divided into three main areas: comfort, energy and environment, where we set human being in the center of the three circles. Comfort is creating buildings that create a healthier and more comfortable life for the people living, working and playing in the building. It's a question about developing buildings that contribute positively to the energy balance, and contributing positively to the energy balance is a question about reducing the need of energy in the building by using the best technologies, and then to integrate renewable energy in the building. And environment is a question about developing buildings that has a limited or a positive impact on the environment. So this is the main issues of the. We have, or the Active House Alliance has developed a specification that set buildings into a quantitative criteria and qualitative criteria. The quantitative criteria is criteria for comfort, energy and environment. They can be rated from 1, which is the best, till 4, which is an acceptable level. On the comfort, we focus on daylight, thermal environment for the winter and the summer, indoor air quality. For energy, there's a focus on the energy demand, reducing the need of energy, and then there's a focus on renewable energy supply, integrating renewable energy into the building, the plot, or in the nearby system, or in the energy system for the region. Primary energy performance is the energy demand minus the renewable energy supply, and the best solution would be to have a house which has a primary energy performance of 0 kilowatt-hour per square meter. On the environment, there's a focus on environmental load through the lifetime of the building. There's a focus on fresh water consumption, and there's a focus on sustainable construction, which is mainly an issue about how to source material for the building. The qualitative criteria is a checklist which one can fill out and inform about how have I thought about those qualitative criteria. When the building, or when each of those parameters has been rated, it will be possible to put it into an Active House radar, where you can put in the score from 1 till 4. So by this you can develop a tool that can be used in a dialogue between architects and engineers, or between architects or between engineers. It's a tool that can be used in the process of developing the project, but it's also a tool that can be used in the dialogue with the investor, the house owner, the private house investor, the end user, in order to identify if we have reached the best level for each of the 9 parameters, or if there are some areas where we would like to perform a little bit better. If you have reached a level of class 3, you have reached, as an average, you have reached a level which would be described as a good level. It is above what is the average level of buildings, so you are good. If you reach a level of 2, you are better than what is standard solutions. And if you reach a level of 1, you have reached the best level that you can expect. Members of the Alliance has a tool that they can use to calculate the score of the Active House parameters, and which can give them the Active House radar. It's an Excel sheet where one put in the information that one have from the designed project. When I'm saying the designed project, it's mainly the topics that you have to focus on when you apply for the building permission, and that means that you have to put in data that you already have available. One might have to change a few things in that area. However, there is one topic which is normally not included in building permission, and that is the environmental issues, and those could be new. And there's also a tool which can help the members of the Alliance to put in the data. However, those tools are only available of members of the Alliance. The second edition of the specification can be downloaded from the Active House homepage, and for this conference here, a few version has been brought and can be handed out for those who would like to have a printed version. But it is the specification can be downloaded free from the Active House homepage, www.activehouse.com. Active House can be compared to other schemes. Active House can be compared to Minergie and Passive House, which is equal schemes, and Active House can be compared to GDNB, BREEAM and LEED, which is more developed schemes with a much higher complexity than Passive House and Minergy and Active House. But starting with Active House, the main focus is holistic, 3 main criteria, no specific requirement to products. 9 topics are evaluated. The certification costs are free from members who can use the tools themselves. It focuses on comfort, energy and environment in a balanced focus. Minergy is a system which have an overall energy focus and set requirement to buildings from 0 till 38 kWh per square meter. There are 3 levels: standard, Minergy P and Minergy Plus, and then there is an add-on which is an environmental add-on called Eco. Minergy Plus Eco version can be compared to Active House. The complexity of Minergy is almost equal to Active House. The certification costs is a little bit higher, or is higher, and people have to pay to make the certification of a Minergy project. Within energy, Minergy and Active House has the same focus. Comfort is a little bit less focused in Minergy, and environment is even lesser focused in Minergy than in Active House. Passive House is a well-known solution, and one could say the first solution for energy efficient housing. Therefore, it's also mainly focusing on energy for heating with the trace barrier of 15 kWh per square meter. There's a requirement for primary energy use of less than 120 kWh per square meter, and this includes energy use for the building, the technical installation, and for the appliances. There are a number of specific product requirements that need to be fulfilled. The complexity is not that high. There are 3 main topics evaluated. The cost for certification is on a medium level. Comfort is evaluated on a relative low value. It is included, but it's not a primary focus. It's mainly thermal comfort that are focused on. On energy, there's a very high focus on that, and you can compare that equally to Active House. And on the environment, I would say that there is not any requirement to Passive House at the moment. Moving to the GGNB, BREEAM and LEED, which is a larger scale scheme, mainly focused for professional building sector, large building, offices, public building, schools and so on. There's a huge amount of topics which need to be evaluated for all 3 of them. The costs for the certification is quite high, but they are very much balanced in the way they are looking into comfort, energy and environment, and they are all looking into the 3 parameters, and they are doing it on a level which can be compared to, equal to, or even more detailed than the Active House. The Alliance has identified a number of projects, or developed a number of projects that is uploaded on the homepage, on the Active House homepage. Other projects are uploaded as well. Any architect or any engineer can upload their own projects. All they have to do is to evaluate the building based on the Active House vision, comfort, energy and environment, and then we will use them and present them on relevant conferences. So I will take the opportunity here to ask any one of you to upload the projects that you would like to have circulated through the Active House network. You can upload them for free on the homepage. You just need to inform about how you have worked with comfort, energy and environment. The Active House Alliance has worked with the specification for a number of years now. The first edition was published in 2011 and the second edition was published in spring 2013. There are some good experience in how to work with the specification and how to work with the radar tools, and that will be presented. The first project I will focus on is the Great Gulf Home Active House in Toronto, Canada, which is a newly opened project. It opened in October 2013. It is a project that has been focused on the balance between comfort, energy and environment. And one can see that they have made the best score in many areas. One can use the radar to evaluate the standard level of buildings, and that is what have been done here with the project in Canada. What you see here at the right side is a standard level for new buildings in Canada. One can see that it reaches a good level for environment and comfort, and not a very good level on the energy issue. But this is standard. This is how new buildings are built in Canada, and one can see that the Great Gulf Active House has been developed with a wider focus on comfort, energy, and environment. And one can see that the comfort level and the energy level has reached the almost best available level for buildings, and that is by far above what is standard in Canada. One can also see that on the environmental issues, the level is also far above what is standard, but still it's not on the highest level compared to the level reached with comfort and energy. One need to keep in mind here that reaching a class 1 for all 9 parameters would be quite difficult and quite expensive. However, one can use the radar to evaluate the standard level and show how the performance of the specific building are better. Another project which is relevant to show is the Montfort renovation project in Netherlands. It is an existing building stock which has been renovated from 1970 level to Active House level. And you can see the difference between the two types of buildings in the picture here, where the left picture shows the Active House level, and the right picture shows the right building in the picture shows the standard solutions. The architect has worked with the Active House philosophy by opening up the building, getting more daylight into the building, and focusing on the indoor environment and fresh air supply. They have optimized the building in the way that they have insulated the building further, and also a big insulation in the roof and in the facade. Then they have also looked at the environmental issues by looking into how grey water can be reused for other purposes in the building. So the Active House has been used. The Active House philosophy has been used by the architect to run through comfort, energy, and environment issues. One can here take the starting point in the existing building, and the light green color shows the performance of the existing building before the renovation, and one can then see how the architects and the engineer has tried to optimize the building and moved it from standard level for 1917 buildings to best level on the comfort and energy performance of buildings for 2013 or 2014. So they have reached the nearly zero energy buildings level on the energy. They have reached the solution with a high and a good indoor comfort level, and they have also performed better on the environment issues, but it also looks clearly here on the radar that could be performed even better. But it can be difficult in an existing buildings project to Finally, a link to the homepage where you can subscribe to newsletter and follow the development of the Active House Alliance. You can also register on the homepage, and then you will get further information about what is going on. And you will also be able, if you have registered on the homepage, you will be able to give input to the homepage as well. Finally, on behalf of the members of the Active House Alliance, Thank you for listening to this presentation. You can join the Alliance and follow the development of on www.activehouse.info. And if you would like to get in dialogue with the Secretariat, you are welcome at secretariat@activehouse.info.